Hello, I'm Mahendra Shetty, founder Yes Mahindra Academy. In this session, we are going to study the applications of simultaneous linear equations in two variables. Here we have an exercise in which we have to find out the set of simultaneous linear equations in two variables. For case 1, we have a condition, that is, the age of Sarthak is X year, that is, the present age of Sarthak is X year, and the present age of Sakshi is Y years. Now, we have to find out the equations for solving the variables X and Y. The condition 1 is the sum of present ages of Sarthak and Sakshi is 25. Means the addition of the present age of Sarthak, that is X years, plus the present age of Sakshi, that is Y years, and the addition or the summation of these two variables is 25. The second condition here given is Sarthak's age is less by 8 than double the age of Sakshi. Now we know the age of Sarthak, that is the present age of Sarthak, is X years, and the present age of Sakshi is Y years. Now the Sarthak's age is less by 8 than double. Double means multiplied by 2. The age of Sakshi means 2y, the double the age of Sakshi, and the age of Sarthak, and the difference is 8. Here the condition is satisfied, that is Sarthak's age is less by 8 than double the age of Sakshi, that is 1. Here the third condition is 4 years ago Sakshi's age was 3 years less than Sarthak's age at that time. Means before 4 years the age of Sakshi will be Y, the present age, minus 4 years, and the age of Sarthak will be X minus 4 before 4 years. So here the condition is 4 years ago Sakshi's age, means this quantity, was 3 years less, means the difference is 3, than Sarthak's age. Now the Sarthak's age at that time was X minus 4. So the difference, that is X minus 4 minus Y minus 4 is equal to 3. So in this way we can find out the equations for the given condition, and we can use these equations like x plus y is equal to 25 to y minus x is equal to 8, x minus 4 bracket minus y minus 4 bracket is equal to 3. So these three equations are related to the same condition, that is the age of two candidates. So therefore we can use two equations out of these three for solving the unknowns, that is the present age x and y of the candidate. So in this way, we can use simultaneous equations for the solving the condition or the find out the variables of that linear equations in two variables. Now we will move towards a simple example. Here a rectangle is given. As we know, the rectangle has equal dimension of opposite sides. Therefore, here a condition given is one of the side of the rectangle is 2x plus y plus 8 and the other side is 4x minus 1. And the smaller side, one side is represented by 2y and other side is represented by x plus 4. But we know that the opposite sides of the rectangle are similar. Therefore, we can equate both sides as first 2x plus y plus 8 will be equal to the opposite side, that is 4x minus 1. And after simplification, we will get 2x minus 4x plus y plus y is equal to, this constant will be minus 8. So minus 2x plus 2y is equal to minus 8. This will be equation number 1. And second condition, that is the smaller side, 2y is equal to x plus 4. So after simplification, we will get x minus 2y is equal to minus 4. This will be equation number 2. So we have to find out the perimeter and the area of this rectangle. And before finding out the perimeter and area, we must know the dimension of this rectangle. So first we have to solve the simultaneous equations for the variable x and y. So the equations which we have, 2x minus 2y is equal to 8 and x minus 2y is equal to minus 4. So now we will find out the solution of this equation. So the equation 1 is 2x minus 2y is equal to 8. This is equation number 1. And x minus 2y is equal to minus 4. So for eliminating the variable having the same coefficient, in this case we will subtract equation number 2 from equation number 1. So it will be minus plus and plus, and the result of this equation will be 2x minus x minus 2y and plus 2y will be 0, and 8 plus 4 will be 12. So this is the value of variable x. Now for the value of variable y, we have to substitute this value either in equation 1 or or equation number 2. So after substituting this value in equation number 2, we will get 12 minus 2y is equal to minus 4. So minus 2y is equal to minus 4 minus 12, that is minus 16, and y will be minus 16 upon minus 2, that is 8. So the value of variable x is 12 and variable y is 8. Now we have to calculate the perimeter of the rectangle, and for perimeter one of the side is 2y and other side is 4x minus y. So if we multiply the addition of two sides by 2, we will get the perimeter of the rectangle. So after solving the equation, we have got the value of y as 8. So it will be 2 into 8 plus the value of x as 12 minus the value of y 8 and multiplying factor 2. So the solution will be 16 plus 48 minus 8 into 2 and 64 minus 8 multiplied by 2. So 64 minus 8 will be 76 into 2, sorry, 56 into 2, and the answer will be 112 unit. 112 units. Now for area of the rectangle, we have to multiply the two sides, that is 2y into 4x minus y. So here the value of y is 8 and the value of x is 12. So the answer will be 16 into 48 minus 8. So here 16 into 40. So the value will be 640 square units. So in this way, we can use the simultaneous linear equations in two variables for calculating the values of the given condition. In next example, we have the condition like this. I have some analog wristwatches and some digital wristwatches. I'm going to sell them at a discount. The day one sale is like analog watch sale is 11 numbers, digital watch sale is 6 numbers, and the total collected or received amount is 4,313. And the output of sale on day second is number of analog watches sold out was 22 and digital watches sold out was 5, and the total amount received was 7,330. We have to find out the selling price of wristwatch of each type. So we have to assume the selling price of analog watch and the selling price of digital watch. So we will assume as selling price of analog watch as X rupees and selling price of digital watch as Y rupees. So here at day one, the total amount received by sale of analog watch will be 11 into X, and the total amount received by sale of digital watch will be 6 into y, and the total amount received will be the addition of the sale of these two items. So the equation number 1 will become 11x plus 6y is equal to 4330. For the second, the amount collected from the sale of analog watches will be 22 into x, and from the sale of digital watches will be 5 into y, and the total amount collected will be the addition of these two quantities. So therefore the second equation will be 22x plus 5y is equal to 7330. So we have got these two equations for same condition. So we can assume both equations as simultaneous linear equations in two variables, and after solving this equation we will get the amount of, that is the selling price of wristwatch of each type. So we will move forward for solving of these two simultaneous equations, and the equations are 11x plus 6y is equal to 4330, the equation number 1, and 20x plus 5y is equal to 7330, the equation number 2. So we will solve these equations simultaneously. So here 11x plus 6y is equal to 4330, equation number 1, and 22x plus 5y is equal to 7330, equation number 2. After observing, if we multiply equation number 1 by 2, we will get 22x plus 12y is equal to 8660. So this will become a new equation, that is equation 3. Now we will subtract equation number 3 from equation number 2. So 22x minus 22x will be 0, 5x minus 12y will be minus 7y, and 7330 minus 660 will be 1330, and that will be negative. So therefore y will be minus 1330 divided by minus 7, and the amount will be 190. So therefore the selling price of digital wristwatch is 190 per unit. Now we have to calculate the selling price of analog wristwatch, and we will find out that value by substituting y is equal to 190 in equation number 1. So the equation number 1 will be 11x plus 6 into 190 is equal to 4330. So 11x plus the multiplication of 6 into 190 is 1140. So 11x is equal to 4330 minus 1140, and the value is 3190. So x will be 3190 divided by 11. and the answer will be 290. So the selling price of analog wristwatch is 290 rupees. In this equation, we have two conditions. First condition is a boat travels 16 km upstream and 24 km downstream in 6 hours. And the second condition is the same boat travels 36 km upstream and 48 km downstream in 13 hours. Find the speed of water current and speed of boat in still water. So we have two variables here, means two things we have to calculate, that is the speed of water current, we will assume it as x, and the speed of boat in still water, and we will assume it as y. So the speed of water current will be assumed as x kilometer per hour, and the speed of boat in still water is assumed as y kilometer per hour. Now, moving with the water current, the boat will have the speed equal to its own speed and the speed of water. But while moving towards upstream, the speed of the boat will be reduced by the water current which is passing in an opposite direction. Therefore, moving towards upstream will have the net speed as x minus y kilometer per hour, and moving with or moving towards downstream, the net speed will be 8 plus, x plus y kilometer per hour. Now, here a condition is given: a boat travels 60 km upstream and 24 km downstream in 6 hours. So we have to convert this 16 km, 24 km with the help of the speed in time. Now we know the speed is equal to distance traveled divided by time. So for calculating time, we have to convert this equation as distance traveled upon speed. So for condition 1, the distance traveled upstream is 16 km and distance traveled downstream is 24 kilometers. The speed for upstream is x minus y kilometer per x minus y kilometer per hour, and for downstream it is x plus y kilometer per hour, and the total time required is 6 hours. And for condition second, the boat travels 36 km upstream and 48 km downstream. So the speed of for upstream is x minus y kilometer per hour and x plus y for downstream. So the addition will be 13 hours. So in this way, we have got two equations, equation number 1 and equation number 2. So after solving these two equations simultaneously, we can find out the unknown, that is speed of water current and speed of boat in still water. So here we have got two equations, equation number 1 and equation number 2. Now these equations are not linear equations. So first we will convert these equations in linear equation by substituting x minus y as m and x plus y as n. So here, after substituting 16, 1 upon x minus y as m and 1 upon x plus y as n, the equation will be designated as equation number 3. And 36 into m plus 48 into n is equal to 13. This will be equation 4. In this equation, remember one thing, we have substituted 1 upon x minus y as m and 1 upon x plus y as n. So for eliminating one of the variable, we have to multiply the variables by the coefficient from the alternate equations. So here we will multiply equation number 3 by 2. So it will be 32m plus 48n is equal to 12. This will be equation number 5, and after subtracting equation number 5 from 4, we will get 36m minus 32m. It will be 4m. 48n minus 48n will be 0, and 13 minus 12 will be 1. So m will be 1 upon 4. So here the value of m is 1 upon 4. For finding out the value of n, we will substitute this value in equation number 3. So the equation number 3 will be 16 into m means 1 upon 4 is equal plus 24n is equal to 6, and 4 1s are 4, 4 4s are 16. So the equation will be 4 plus 24n is equal to 6, and 24n is equal to 6 minus 4, that is 2, and n will be 2 upon 24, that will be 1 upon 12. So the value of m will be 1 upon 4, and the value of n will be 1 upon 12. So by substituting these values in these terms, we will get m is equal to 1 upon x minus y is equal to 1 upon 4, and n is equal to 1 upon x plus y is equal to 1 upon 12. So the value of x minus y will be 4, and x plus y will be 12. So by adding these equations, we will get the value as 2x is equal to 16 and x is equal to 8. And by substituting this value in equation number 6, we will get the value of y as 8 minus y is equal to 4. So minus y will be 4 minus 8, that will be minus 4, and y will be 4. So here we got the values of x and y. So the value of x is 8, and the value of y is 4. So the speed of the water current will be 8 km per hour, and the speed of boat in still water is 4 km per hour. So in this way, we have studied the applications of simultaneous linear equations in two variables. Thank you. We'll meet soon with other topic. Thank you.